Okay, I'm not an Aggie, but the previous speaker was an Aggie, but I teach Aggies. So that's how we get classes started and quieted down. So I'm going to talk about a teaching tool I've been using for the past few years. It's grown over time. And the title, as you can see, is Creating a Browser-Based Virtual Computer Lab for Classroom Interaction. And I work at the Department of Atmospheric Science, and we actually have an undergraduate course in programming where we teach Python. So this is based on some of that work. So if you want to follow this talk, it's actually available as a markdown document. If you see the URL here, the goo.gl URL, it's capital O, J, O, small k, capital J, R. So it's a markdown document on GitHub. If you want to follow along, it's the whole talk's out there. So I'm going to do some demos. I've just set up the demos. So I'm actually delivering the talk using the same tool that I'm going to be describing in the talk. I'm going to skip over this because this tells you how to actually play this as a slideshow in case someone else wants to do that. Okay, so let's get started with what is a computer lab. This is a picture of a computer lab. And there are several things you can notice in the computer lab. And we have some of those in our department and many other places in campus. But they're slowly disappearing. And the talk partly addresses that issue that computer labs eventually are going to go away in 5 to 10 years. Because people have very powerful computers with them that they want to use. One of the things you see is all the computers are the same. So it's uniform software and hardware, which is important if you're asking 20 or 40 people to do exact same thing. And the other thing is the instructor can see a lot of the screens. If I can walk around, I can see what students are doing. And that's really useful because I can see where they're going wrong, whether they're looking at Facebook, things like that. And you see a student raising his hand. So if students raise their hands, I go help them out. So I want a way for students to attract the attention of the instructor. And you see two students talking to each other. And students help each other all the time. And I tell the advanced students, if you're done with your work, go help other people. Because programming is a group activity. And there's a wide range of abilities. Often I get a bimodal distribution in grades. It's like some people can program, some people cannot program. And it's not a bell curve when you teach programming like in other courses. So I ask the more advanced students to help out the weaker students. But as these computer labs disappear, can we replicate some of these features in a software environment? So that's what I'm going to be addressing here. So to summarize, you have uniform hardware and software. You can monitor students' progress by just glancing at the classroom. A student can raise a hand to get attention, can look at each other's screens to collaborate. The other thing which is not visible in the picture is that often we put out files for students to work on, and you need a shared file system of some kind to do that. But physical computer labs have disadvantages. They cost a lot of money. That's one reason they're disappearing. As budget cuts come, the labs slowly disappear. Security, you want the system staff to maintain them, give passwords. Every semester I go and ask for 20 or 40 new accounts. It takes some time. You need root access. I maintain my own laptops and desktop, but they don't give me root access on the lab computers, and actually I don't want it because I don't want them to blame me if somebody breaks in. But sometimes there are glitches which I can't fix. It takes a couple of days to put in a ticket and I get a response to that. So those are disadvantages with the physical labs. And students like virtual labs, I'll talk about in a moment, because nowadays you can do things without being physically present, whereas in the physical lab you actually have to be there to use the hardware. So my background, I'm a climate modeler. I use supercomputers, and I've taught an introductory programming course for meteorology majors for 5 years. Initially, I used IDL. It's not interface definition language. It's actually a numerical language which is used in by NASA a lot. But 2 years ago, I switched to Python because it's more modern and it's just much nicer. And I also dabbled in open source software. I work on a project called GraphTerm. It's a graphical terminal interface. And what I'm going to talk about uses those features. And students like to use laptops instead of the lab computers. It's been more and more true in the 5 years I've taught. Students say I can install Python, Anaconda, or Nthought on my laptop, And that way I can work on homework at home instead of having to do it in the lab. So the question is, can you create a virtual lab where you can retain some of the advantages we talked about earlier? But the other fun thing is, with a virtual lab, you can also go beyond the things you can do in a physical lab. And we'll talk about an example of that. So in a virtual computer lab, you want user authentication, you want user isolation so students can't mess with each other's work. So they can't all share a single Unix account, for example. You want remote access so students can access it from home or anywhere. You want to be able to share files, for the instructor to give files or students working in groups to share files. And the ability to monitor students' progress to find out who's behind and who's ahead. So those are what we'd like to see in a virtual computer lab. And what do we have now? Some of the options are, I use IPython. Students like it a lot. I'm sure many of you have encountered it in some form. It's a very powerful tool, and it's getting more and more powerful with time with the browser-based interface. But right now, IPython only supports single-user server with password. And a multi-user version should be out in a few months, I believe. There's something called JiffyLab, which actually runs a Linux container, Docker, for each user. So students can use that to create a separate Docker account for each person. And there's commercial software like Wakari. It's free with a basic account. It's cloud-based. And there's something called Sage Math Cloud, which also is free, and it creates a virtual account for each person. So these are some of the options that are there for virtual computer labs, Python-based solutions. So since I already had a software that could do some of these things, I decided to extend it and extend GraphTerm to support a virtual computer lab. And the way I set it up was to create an automatic Unix account for each student. So when a student logs in, there's a group password that I give them in class, and they type the group password and it automatically creates an account. And one thing I hate doing is getting passwords, because people reuse passwords, and that's pretty much the only secret thing or sensitive information that's on student computers. So I decided I didn't want to use any passwords, so they either have a very long access code that they can put in their phone and copy it every time to access a computer. It's randomly generated code. Or they use Google authentication, so they can use the Google account to authenticate. So they don't use their passwords. And apart from passwords, the only other thing that's there on their accounts is their homework and stuff, which doesn't need to be that secure. And students had a choice of either using an IPython Notebook server or using GraphTerm built-in notebook interface, which is a simple version of the IPython Notebook interface. And the collaborative features we'll talk about in a moment that they could use. So the two options: if you already have a computer, a physical server, it takes about 2 lines to download GraphTerm and install it and start up a server daemon on a certain port, so then it becomes a virtual computer lab. Or you can launch Amazon Cloud Instance, which actually I did for a demo for this talk, and we'll come to that in a moment. It takes about 5 minutes for the whole system to set up with all the Python software. So as I mentioned before, students use a group code, and then they use user-specific code. This is what the screen looks like. You have username and a code, or they can use Google authentication. So you go to the next one. So this is the demo machine I set up. So those of you who are on the laptops, you can go to a browser, and if you want to, you can just type in this URL. It's lab.gterm.net. So if I have a couple of people typing in, we can actually see the monitoring features live if I have enough users. But if you type in this URL, you should see a screen like this. I'm going to sign out. Actually, this is what you should see. There's actually a terminal embedded in the terminal. So this is what you should see. So type in any username that you like, and then type in the group code, and the group code is PyTexas2014. The letters are all lowercase. So if you do that and click authenticate, you should be able to create a user. So if I do that, pydemo2, just going to copy paste this. should create one. Oh. Let me see if that. I'm just going to a terminal to see if that went out. It's PyTexas 2014. That's all lowercase, but I'm just having some trouble here. Anyway, I don't need the demo to complete the talk. Okay. Did anybody get through? Okay, some people did get through. It's just slow? Okay. I picked the cheapest Amazon instance to create it, so that may be part of the problem. Okay. Oops, we do have all these users. So this is what I see in a computer lab, that I see all the users, and I logged in a super user, so I can actually go in and look at individual users' terminals. So I'll get back to the talk, and we'll come back to this lab setup later. So the instructor can view students' terminal sessions at any time. Feel free to play around in the terminal window that you get. It's a virtual machine, so you can't do much damage to any of my desktops or laptops. For group projects, students are allowed to share. They can view each other's terminals, but normally, unless they enable that, they can only look at their own terminal. And there's a simple chat feature, so you can actually chat with the chat messages superimposed on the terminal. So you can discuss what's on the terminal and ask questions to the instructor. Here's an example of some of the things you can do with the terminal interface. You can do simple notebook plotting. So there's a demo. I'm running a live demo here. So if I want to plot something in the terminal, this is what it looks like. So you can plot right within the terminal, and I can change the plot. So I'm using matplotlib. So you can plot embedded in the terminal, so we can do contour plots and line plots. You can also view notebooks. So here I'm going to open up a notebook here. There's a command called GPython that'll do that. So this is the fluid dynamics lesson, an online IPython notebook. So you can see the text and the figures all embedded in the notebook. So these are some of the things that students do, and we'll see. So this is an actual screenshot from my spring class, where you have all the students opened up different terminals. It tells you how idle the terminals are. And I often ask students to open up, they're doing a quiz, to open up a terminal named quiz, so I can actually look at that terminal and see how they're doing with the quiz. And if you click on these, it'll actually open up that student's terminal, so I can actually see what the student is doing real time. And and I can communicate using the chat. So it sort of emulates the physical lab feature where you can look at what people are doing directly. You can also create frames like matplotlib frame within the terminal. So here I'm looking at what 3 students are doing. The terminals have name, the student name and the terminal name. So this is student 1, student 2, and student 3 has completed the plot, and the student 2 is having difficulties with error messages. So you can see that live as they're working in the lab. How much time? 10 minutes, okay. So one of the fun things you can do here is you can go beyond what you can do in a physical classroom, and you can have what are called fill-in-the-blanks notebooks. And since I only have about 5 minutes of talk time, I will skip the description here. You can look at it later, but I'll just describe what it is with actual examples. So what the notebook looks like, it looks like a regular IPython notebook, but they're missing pieces. So this is the code cell, if you're familiar with the Python notebook. But here it says fill in the code here and fill in the code here. And the student's asked to define a function that adds absolute values of 2 numbers and subtracts absolute value of two numbers. And the student is expected to fill in the code here. And then the student types Control-Enter to execute the code. And you can do this any number of times to try out different variations of the code. And then when the student presses Shift-Enter, you go to the next cell and you get the right answer displayed, and that's what it looks like here. So if you go to, the student presses Shift-Enter, the student's last attempt at getting the code right is saved in the notebook, and then the correct answer is displayed. And eventually the student can submit the notebook, which will show the last attempt the student made at getting the right code, and also the right code at each step. So you can build questions where the second step depends on knowing the right answer to the first step, which was always a problem because in a complex programming project, they'll get one part right and they'll never get the whole thing right because they're stuck in one part. So here you can go step by step, and each step you get the answers right, and you go to the next part, you can combine the two parts together. So you fill in the blanks progressively. Here's a live demo of that. So this is what it looks like. You open a fillable notebook, and you can type in any code here. Run it once, it gives you error messages. You can change something else, and then run it again. Control-C, Enter. And then you'll get the right answer displayed. I think I pressed the wrong thing. Okay, let me press Shift-Enter. And you get the right answer displayed as well as the wrong answers. Here's a form that you can use if you want to launch your own cloud instance for the virtual computer lab. You check all the boxes you want. You want PyLab or NetCDF or R, and then you can launch a virtual instance. And you can manage the virtual instances too within the terminal. So you get a list of all the virtual instances that are running, and whether you want to kill or whether you want to log into them, you can do that. So some of the shortcomings, if you use a cloud server for Amazon or something like that, it's not free, it costs money. But if you have your own physical server, then you can just use it to create a virtual computer lab. Obviously, you need good internet connectivity, and that's important because things are going to happen from the server rather than from the local computer. Right now, the client only runs on Mac. The client runs on all the platforms which have browsers, but the server only runs on Mac and Linux. It's a Unix-based server. It's pure Python, but it uses Unix-like features which are only available in the Unix version of Python. The notebook interface is convenient, but one thing I find is if I use the notebook too much, students forget about the directory structure and the basic organization of the computer system. They get lost as to where they are in the directories, and notebooks, it makes it too easy for them. So I need to go back and teach them more shell commands before I get to the notebook. So conclusions, virtual computer lab can duplicate some of the advantages of a physical computer lab. You can have terminal sharing and chat features. You can combine the command line and the graphical user interface. I know there's a parallel talk going on right now on the command line interface. And I would have gone to that talk because I like the command line interface, but I also like my graphics in my command line. So virtual lab can do things, I should say boldly, do things where things that you can't do in a physical lab. You can do fill in the blanks notebook assignments where you can progressively reveal answers to a complicated problem, and people get to solve the end of the problem knowing the answers to all the previous parts of the problem. So you get incremental scaffolding. Some of these features will appear in IPython Notebook eventually, and I know there'll be a multi-user version available soon in IPython Notebook. So if you want to look at the project, you can look at GitHub, mytotic/GraphTerm. The talk itself is here in this URL. So in the next couple of minutes, I'm going to go back to the live computer we have, and let's see what the users are doing. So here I see all the users who are here, and I'm going to log in as the super user. I'm going to create my own terminal. So this is an administrative interface. So it tells you how many users are accessing the computer and how idle things have been. So let me pick on this user. So this is what this user has done so far. And if they're doing graphics, you'll see the graphics. And you can actually embed graphics in there too. And actually, the super user can take control if you want to handhold the student's work. Let me see if that. But this user has to give me permission to do that. So this user, if you want to let me control the terminal, go into share and uncheck the locked and private ticks, then I can control your terminal. Oh, actually, there's another way I can control the terminal too. I'll detach. And I can. So now I have control of the terminal and the student doesn't. But we can go back and forth using this. There's a steal button, so we can go back and forth with the control for the terminal. So I'm going to, well, the other thing is chat. I mentioned we can do chat. Let's see. So it's a very simple chat feature, and I can and the student can actually go click the chat button, and what the student types will also appear on top of the terminal. And we can have a discussion about what the student's doing real time on the terminal itself. If the person who has this terminal, if you want to click the chat button and type something and send, it should appear there. Okay, I'll take questions. Any questions? Anyway, I'll leave it on for the rest of the day if you want to. Yeah.
The users that you're teaching Python to,
Uh-huh.
have they programmed?
No, many of them have not. I usually start, the first question I ask is, have you programmed before? Usually a couple of them, gamers usually, have programmed. But most of the other programming is Excel macros. That's the best they have from high school.
Are these graduate students or
Undergraduates. They're usually sophomores, freshmen. So it's a bit of a challenge, but Python's a good language. Yeah. One problem we have is that there's too many resources for Python. If they go online and search, they get overwhelmed with stuff. So you really have to curate what they look at.
And do you target the exercises and the programming things that you do to atmospheric sciences or meteorology?
Yeah, a lot of it's to do with plotting two-dimensional pictures. So we focus on that. Oh, question there? What can be done in the chat? The chat only does a few basic things. Oh, some of the things you can do here, you can do plots. Here's a summary of some of the things you can do here. So here, opening up 6 terminals, and you see a different demo on each terminal. So it's like matplotlib. So you can divide any terminal into subframes, and you can actually have frames within subframes. And so the top middle, you see the weather in from Yahoo. This is just a presentation like the one I just did. This is basic plotting, a sine wave in an IPython notebook. And this is basic matplotlib animation. Any other questions? Thank you.